Hello everyone. Good afternoon, good day. How is everything? Thank you for joining our today's webinar. Let's give it like 2 minutes, 2 more minutes to let more people join to have a good participant number. So today we'll be speaking about the different solutions from the drone to the oil and gas field. It's an important field that the drone can cover. So hopefully it will be knowledgeable for you guys to have a fully idea about these different solutions that the drone can offer. So let's give it one more minute. Then we will introduce ourselves. Then we will get started. Okay. Yeah. I think we can start, right? So before we start the slides, let me first introduce myself. My name is Yahya, and I work in advanced media as a creative solutions engineer dedicated for the different drone solutions. And here I have with me my colleague Pavel. Pavel, if you'd like to introduce yourself.
Nice to meet you all, everyone. My name is Pavel. I'm working as R&D head for NNTC, it's a Dubai-based company who specializes in drone technologies, in artificial intelligence and video and image processing. So one of the reasons why I'm here today is basically to speak about how drone technologies and how advanced AI technologies and different sensor integrations can help to oil and gas industry to prosper and to make business more efficient.
Perfect. So before we start the main topic, let's give some time to speak about our companies. So Advanced Media is a company established in 2002, and actually next month will be the 20th anniversary of the company. AMT actually is the biggest market in the GCC for the different broadcasting, audio, video equipment, and we are as well an authorized distributor for DJI in the Middle East and North Africa, and we have a service center for DJI and for the other brands as well. Pavel, if you'd like to just brief us about the NNTC, it will be great.
Sure, yeah, thank you very much. NNTC was established in the region around 5 years ago as a representation office for the Russian IT group. And as a local entity, we represent different software solutions from our group of companies, and one of them actually is dedicated for drones. And as far as we go for the drone technology, there is a specialized company in the group called SPH Engineering, which does only the business around the drone technology. So we develop a special software to control the drones, to monitor operations, to process the imagery, and to integrate drones with a specific payloads.
Perfect. About DJI itself, we should give the time to speak about DJI. DJI company started in 2006. They started with the basic different items like the flight controllers, and now they kept on growing and developing until they reached the top level. And now in 2022 they have different solutions for different sections, and the oil and gas is no exception for this. And DJI as well, they has been working with different oil and gas companies around the world. A very interesting example of this in the Middle East is the Aramco. They've been working as well in the Total, the European company. So they have a very good experience with, and they have a very good practical different products for this kind of field. We will be speaking about them in more details in the next slides. So what we will be covering in this presentation is the overview about the oil and gas solution, the pipeline inspection, the refinery station inspection, and the oil field, and last but not least, we will be speaking about the product itself. So as an end-to-end enterprise solutions, basically any solution for the oil and gas will be consisted of different items. So we will have the platform, which is the body, the drone itself, the payload. Sometimes it's inbuilt the drone with the drone. Sometimes we can mount it with the drone. We have to have as well the software. The software have two sides. The first one is for planning the mission, and the other side is for processing and data analyzing as an output. And you should have the training to have the full output or the successful output from the drone. You should have the training. And as a service, as I mentioned before, as a DJI, we have a service center here in Dubai. So in this different solutions that we will be covering in the oil and gas field, we all know that there is a lot of scenarios that the drone can cover. So mainly we'll be focusing on one platform, which is the Matrix 300 RTK, that comes or that it's compatible with a lot of different payloads or sensors or cameras. And as well, we will be covering the different softwares, for example, the ones from DJI Terra for data reconstruction, and the one my colleague Pavel will speak about is Atlas. And UGCS. Pavel, what is Atlas? Or UGCS in general?
Sure. So if we speak about two products which we actually use in a drone solutions, so there are two pieces of this, as you mentioned in the beginning. One is intended for the flight planning and automation. That's the product called UGCS. It's a universal ground control station which allows you to really pre-plan the flights in the details, and then in the field the pilot can execute the flight. The solution is centralized, so it can be used among the big organizations with a lot of drones in operations at the same time. It also provides real-time video streaming to the command and control center to make sure that the supervisors can sit comfortably in an office and supervise what is going on in the field during the operations. And if we speak about the second piece, and that's what is usually gets forgotten every time we speak about the drones, once we collected the data, that can be a lot of data. And now the question is how this data will be processed, how we can really quickly react on what we collected from the field with the drone. And that can be a daunting task, because sometimes drone lands and you have 15,000-20,000 images collected from the inspection object. So Atlas is an AI platform which basically allows you to process the images, stitch them into the maps, and then detect particular anomalies on these images. And the benefit of Atlas is that it's user trainable. So you don't need to come to us every time and say, please find the car on these pictures. What you can do, you can show Atlas how the car looks like yourself, and then next Atlas will do the job.
Yeah, you'll do the teaching, the Atlas will learn, and then you can apply it in a real example.
Absolutely, and that's a real user trainable system. So for example, if you want to find cracks or rust on a pipe, that's basically all you do. You collect the data first, then show the Atlas how these cracks look like, and then next time you fly, you basically identify the cracks automatically. Yeah. Plus, obviously, the report comes out, so it's not just an identification thing. Perfect. So that's basically to complete the inspection cycle.
Okay. We have the drone operation with the command center as well, the streaming solution. You can do it with UGCS.
Exactly, yeah, that's what we mentioned in the beginning about UGCS. Basically, UGCS is not only flight planning solution, it's also the command and control center where the operators can monitor the operations in the field, stream the videos in real time. These videos can be integrated with generic CCTV video management systems like Milestone, Genetec, and others. And Also, it provides georeferenced video streams compatible with ArcGIS, so this can be processed in real time if needed, with a real geographical data in it. So that's pretty much complete solution which covers all the aspects of field operations.
Interesting. So, as I mentioned before, we have in the oil and gas industry, there is a lot of sections to be covered. So we will be covering for the drone solution, what it can be done with a drone is like the exploration and engineering. For example, you can have with a drone surveying mission or a photogrammetry mission to monitor the progress of if you are building a pipeline or if you are building a station. So you can have a routine surveying mission like every week to just monitor the progress, check if there is something wrong with the building itself, take the measurements, and so on. The other thing is the real important thing I want to cover is the pipeline inspection. We know how difficult it is to do the traditional ways of inspection, especially if it's a long distance pipeline. So the drone will give you the solution for this. I will be covering this in the next slides. For the site itself, whether it's offshore or onshore, the drone have a solution for this as an inspection or as an having a 3D model, for example, for data archiving. For the security and emergency, as my colleague Pavel mentioned about UGCS, you can have the streaming solution from a drone directly to the command center, and you can integrate it with the CCTV that you have in the station itself. So you have the full solution for like a patrol, daily patrol for security purposes. So for the pipeline, why we do usually the pipeline inspection, we want to check if there is an error in the construction. For example, as I mentioned, if we are building a new pipelines, so we can just fly the drone to check to have the 3D map of this construction. We can have the drone inspection for to prevent any leakage from happening. Thus, we are preventing any natural disaster from happening from the oil leakage that can be happening from the pipes. So we have the gas leakage detection solution, and in some cases the pipeline are suspended in like a bridge if there is a river crossed to the field itself. So we all know that the traditional ways of inspection are really hard, especially if the pipelines are like very long. You will find the manpowers are equipped with the heavy equipments to just do the inspection manually. So with a drone, the drone can offer you a very practical way to do the inspection. The drone actually can cover like up to 80 kilometers per day for a pipeline inspection, whereas in the normal traditional ways, what you can do maximum is like 5 to 8 kilometers maybe, right?
Yeah, it depends on the complexity how you do that.
If there is, we didn't mention that the environment, what is the environment? Sometimes it's in the middle of the desert. It will make the things, it's way harder to do the inspection.
Mountains.
Yeah, so the drone, it's really easy. You can just sit in your car, plan the mission, deploy the drone, and it will do the job automatically. It's fully autonomous. So as I mentioned, the drone with the drone inspection, you can cover up to 80 kilometers, and along with this, you have a digital copy of the real world. You have the data archive. You collected the data, and you can just put it in your archive to just compare the result between 1 week to other weeks. So yeah, the drone is giving a very practical solution for the long distance pipeline.
I think if we speak about pipeline inspections in general, that's what we've heard from the customers in not only in this region but in others too. The major issue with a pipeline inspection, that's manual inspection when people just drive along it, or maybe they climb it. First of all, they don't see everything. So they see very limited amount of information from the pipeline, or it takes too much time to get everything. Another major issue is that the documentation of the fault, right? Example is very simple. We are driving along the pipeline and suddenly we see that there is something wrong. So how we document the issue? We basically stop, take pictures with mobile phone and a camera, and then later, sometime later, when we arrive to the base, we basically decompile the report. So that's and the third thing is the hazardous areas, right? Mountains, wadis, rivers, and all these obstacles which arises on the field requires people to cross them, and that's not safe. But with the drones, all these issues can be fixed.
It's more easier and it's more practical.
And it's faster.
Yeah, faster, of course. So here we have a scheme of like a pipeline distribution from the OGM to the port. All this distance can be covered with a drone. You have to follow some steps. First, you have to prepare a checklist. Then you will plan the mission using DJI Pilot or using UGCS before you deploy the mission. Then you go to the place, the location, you deploy the drone, you put it in the ground, the drone will take off and start taking the pictures or the gas reading, for example. And then after it finishes, a report will be generated, whether it's like for the gas leakage detection or if you did the data reconstruction as a 3D model, for example. So as well, in the site pipeline, the drone can do a very important job. That, like for example, here we have the M300. It can be equipped with H20T. H20T has thermal camera along with an RGB zooming, very strong zooming camera up to 230 hybrid zooming. 23 of them are optical. So we can see here, like we are in the thermal view, you can see that there is a heat point, and then you can just switch to the RGB camera and do the zooming. You can double check if there is something wrong, for example, in this heating point. The gas leakage detection is another important topic that we have to cover, and the drone is doing very well job for this kind of thing, because we all know, God forbid, if there is gas leakage, it will be like a disaster for the environment and for the manpower that they are doing the inspection manually. So the drone can do this safely from a distance, from like flying above the pipelines, like for 100 meters. So it's a safe distance, and it can do the job really easily. It can give you the reading. I will speak about the products in the next slides. So it can give you the reading, whether it's real-time reading or after the drone mission is finished, you can have the report to have the fully idea about the area that you did the inspection for. You can do for the oil. And
one interesting solutions also, which can be integrated with DJI drones and UGCS software, is basically the oil spill detection cameras. It's very well known in oil industry that oil spills has to be controlled. The oil spills which are happening on the water surface in offshore operations, they have to be controlled, and the oil spills response teams have to act on them to collect the spilled oil. Now, the biggest issue with that particular field of operation is that there are not so many technologies in the world which can really reliably detect the oil spilled on the water surface. There are radars, there are infrared cameras, but they have very low detection rate.
They have its own limitation,
Yeah, absolutely. So what we can offer an innovative technology which is called thermal polarimetry technology, which has very high detection rates and very low false positives. And what you see now on the screen is actually the example of such a detection. That's a natural oil seep in Santa Barbara, California, which is on the ocean surface, and you can see that with different types of cameras. So you see the visible range camera, and where oil spill is almost invisible, but you have also a lot of noise, like sun glints, surface dwellings, and kelp forests, which are visible on visual image. but not oil spill itself. Then you see the thermal. The thermal is an upper right image. Here we are very lucky that actually thermal camera spotted it, but still it's not understandable what is that. Is it a kelp forest?
Yeah.
Is it an oil? Or maybe it's something else. So that's not really clear. From polarization image, from thermal polarimetry image, it's really very specific. So the advantage of the technology is that basically the oil has a very specific polarization of thermal radiation, which allows us to distinguish it from other substances. And that's why you see it as a very bright white spot on the water surface. And we can definitely say, okay, that's a hydrocarbon. Yeah, we can't say is it kerosene or it's crude oil, but we can definitely say it's a hydrocarbon. And then there is a combined image where you can basically locate the image.
Perfect. So as a gas detection solution, you have two options. The first one is to fly the drone manually. It's up to your application. And the other solution is you can make the drone flying autonomously after you plan the mission. So we have like different solution for the gas detection. It's all compatible with M300. I will be speaking about it in just the next slide. So you plan the mission, the drone will go up, and it will do the job automatically. Then you can, like, if there is something wrong, you can locate you can have the coordinates of that you like suspected that there is a problem in this kind of point, that there might be a leakage. So you can locate it, and then you can send someone to double check on it, and eventually you will have the full report with the reading of each along with the pipeline itself. You will have the full report of it. So we have as a product, we have the one from Sniffer 4D. Sniffer 4D, the interesting thing about it, it's like you can put, or you can put inside of it up to 8 gas, like it can read up to 8 gases, different gases at the same time. So this is something really interesting. For example, you can put it as H2S, VOC, CO, SO2, and so on. And actually, the Sniffer 4D, it can take a 4G dongle, so you can connect it to the internet, and then you can open your laptop, connect to a software called Sniffer 4D Mapper, and you will have the real-time camera feed and the real-time gas reading. So here we have from the slide, you can see a visualization of the readings integrated with a GIS map. So you can see the concentration about the gas reading. So we have the red one, which means that there is a high level of a gas in this certain point. So yeah, you have the full solution in this kind of product. So it's really good, and it's really practical to have as a solution. So the other one is I think it's from UGCS. What is?
No, here what we see here is technical details about oil spill detection system, right? Thermal polarimetry. Basically, how it works. We installed the thermal polarimeter. It's a small type of a camera on the drone, along with a visible range camera on the same gimbal, and it integrates with UGCS to do the flight planning and to do the automated reporting. So the typical use case is basically area scan. When we plan the mission along to scan specific area of the sea, and then as a result we see the complete mapped solution, complete map data about where the spills are, and we have the reports about the location of the spill, its size, and approximate volumes.
Perfect.
And the second one is basically gas methane detector system, which is based on a laser absorption technology. It's also can be integrated with M300 and UGCS together. So when the drone will fly, this sensor will definitely can say the concentration of methane gas at the point of where it's targeted.
Yeah. The last solution as a gas detector is the one from DJI. It's U10. It's actually dedicated as well for the CH4 for methane gas. So you can I have to mention something about the M300. The M300 can take up to 3 payloads at the same time. So we have, from this picture, if we can see, we have 3 payloads. So we have the sniffer 4D, for example, at the top, and at the bottom we have the H20T, and we have a spotlight to increase the solutions possibility. So this is a good thing about the M300. For U10, it's dedicated for the CH4, as I said, and the detection range is from up to 100 meter. It's more than enough, and it's a safe distance from the pipes. So I want to show you here a video about how the mission can be deployed autonomously. So let me play the video. Yeah, so we planned the mission first. This is using the application of the U10 called Alpha. So we planned the mission first, Alpha 1, yeah. Is it working? Or, yeah, sorry. So after we plan the mission, the drone will generate a path to follow, and we just enter the flight parameters here before we hit the start button, and the drone will take off and start following the path autonomously, follow autonomously. You don't have to do anything here. This is the path. You will have the real-time reading, and eventually you'll have a full report after the mission is finished. So here the drone is going to the starting point. And you can see. So sorry for this technical issue. Here another video about how the real-time reading can be done with a manual flying. So here we are flying the drone manually, and here we can see the point of laser, and then if we can see, this chart is the real time reading of the density of the methane. So you have the 2 options. It's up to your application. If it's like something really small, you can just do it manually. If it's like a long distance or a big area you want to inspect, you can plan the mission, and the drone will be doing the job automatically. So what can be done with the gas detection sensor is you will have the real-time gas concentration reading. You will have the concentration curves and value displaying. And actually, there is something I want to mention is you can put an alarm. For example, if there is you can put a value like a threshold. If it's exceeded this threshold, an alarm will start beeping that there is like in this point there is a high level of gas. So you go there and you double check. And it's, as I said, it's fully autonomous. It's up to your application. A good example of this, if you can see the presentation here, we have the case study when in some cases the pipelines are located in a steep mountainside. Sharif, you can put the presentation. Sometimes it's located on a steep mountainside, so and most of the time it's fully covered by vegetation. It's hard to reach, so the drone here can offer itself. So the drone instead of let the manpower going there, it's hard, it's area hard to reach area, so the drone will fly from a safe side and do the job for you for this kind of thing. For the refinery as well, the different application that you can have, it's the utility inspection, of course, the digitalization, if you did the photogrammetry mission for the station, and the emergency response, you can like stream directly to the command center. So here is an example, a video I want to play about the tank field. Like if you want to inspect it, you can here do it manually. You can fly the drone and using the H20T, is it playing? Yeah. I think it's not playing. So this is the tank field. You can just fly the drone and zoom in, zoom out. As I mentioned, it has the 230x zooming capability. 23 of them are optical zooming, so there is no loss in the resolution. So from a safe side, you can fly the drone and just navigate and inspect.
I think we can add here that with using UGCS, we actually can do very interesting inspection automation. What we can do, actually, we can scan the facility with LiDAR or with photogrammetry scan and put the 3D models into UGCS application for the future flight planning.
Perfect.
And you have the whole facility in 3D in order to pre-plan the mission and then repeat these missions as often as you need.
It's like a routine
so
mission.
you make it really routine.
Yeah,
it's not a manual anymore. So that makes routine inspections much faster.
Perfect. Yeah. Another thing I want to highlight is in the utility inspection. Here we can see from the slide, we have the cooling device. If you can see the top picture at the top, it's a normal RGB picture that you can see that there is no problem here. But once you switch to the thermal camera, you can see the difference. You can see that there is heating differences between the points. There is abnormal heatings. So you can just take the measurements and inspect, and you will notice that there's a problem here. So you will send someone to like the maintenance team to just start fixing the issue. And I think here, Pavel, we can use the Atlas as well for the detection, for the thermal detection, right?
Indeed, yeah. Because the interesting thing about Atlas is that Atlas can actually work with any type of imagery. It can be visible imagery, it can be thermal or multispectral, and we can train the system in order to detect, for example, hotspots on cooling devices, and that actually helps to process the imagery. Again, when it comes to routine inspections, UGCS and Atlas, both applications, will help to really improve the performance of that and make everything documented and very well automated. It doesn't fit well for the manual inspections when you do it once, but if you don't have something to inspect on weekly basis or monthly basis, that's where we can really improve your results, and we can really save a lot of time and effort.
Perfect. For the torch tower inspection, usually the traditional ways is letting the manpower to climb these flares or the torch tower, and we have to turn off the flares. So in the drones, we don't have to do this. You don't have to turn off anything. You can just, from a safe side, safe distance, fly the drone and start inspecting. Start the inspection process to these torch towers and have the measurements and the analyzing as well. Another example is for the H20T is the thermal or the night pipeline inspection. Sometimes you need to do a night pipeline inspection, so the thermal camera here, it proves itself, so we can play this video. We see here in the slides, we have these stressed lines here. You can see that this is pipelines, okay, because of the high temperature. So if there is any leakage, it will be obvious, because this thermal will be distributed in the point of the leakage, right? It will be distributed in the ground here. So you will notice that there is something wrong. There might be a leakage, so you can send someone to double check it. So the GPR as well, it can play a very good role in the oil and gas.
Yeah, absolutely. That's an interesting thing, right? So in oil and gas, the pipelines and other infrastructure often goes in the places where there is no even terrain. So typically when it comes to ground penetrating radar applications, what you see, you have GPR mounted on a cart or on a trolley. And that trolley is being pulled either by humans or by car over the ground, which need to be inspected. Now, when it comes to remote areas, there is no straight roads, there are no pavement, there can be uneven terrain. And that really starts limiting the GPR operations. So the efficiency of that, the speed of that, and so on. So drones and integration of GPR with a drone changes this game completely by doing basically two things. We integrate the GPR into the drone as a payload, and the second thing which we do, we integrate the true terrain following sensor to the drone, which enables us to fly drone on the heights of just half a meter.
Oh.
And those who knows GPR technology very well probably aware that the lower the GPR above the ground, the more efficient it is.
Yeah.
So that's a matter of energy dissipation. So now when we have such a capability to fly just half a meter above the ground and follow any uneven terrain, we can use GPRs in the places where it was completely impossible before. Perfect. Think about dunes, think about mountainous areas and so on, where you just literally can't fly the drone manually in any conditions. Another interesting thing, for GPR to get the best results, you need to have the constant flight speed. And imagine yourself flying a drone manually over the steep slope and keeping the same speed against the slope. That's absolutely impossible for humans.
It's really hard, yeah.
So, but it's not impossible for the automation. So with all these integrations, GPR becomes really important.
Perfect. So you will have the altimeter for the terrain following along with the GPR. So,
absolutely, yeah. They're both integrated. And UGCS will keep exactly the altitude we need for GPR operation, and the data will be collected. So there two things will happen.
And it is compatible with the Metris 300, right?
Yeah, absolutely. Okay. Yes. Currently, we do support M300 with completely. Yeah, that's just an example on this slide. What you see, that's example of actually pipeline inspection. This pipeline was laid down in one of the Baltic countries many years ago. There is obviously the pipeline plan, but unfortunately nobody knew exactly where are the pipes. So yeah, they are somewhere in the place, but there is no precise data, like how far is it from particular reference points. So what was done here, actually, GPR was flown above the pipeline to scan the area, and we determined the exact location of the pipe with a precision of a few centimeters. So that's how it actually helps in many cases.
Perfect.
Another integration which we also provide, we provide the magnetometer integration with the drone. Exactly the same concept. We can keep the constant altitude, we can keep the constant flight speeds, but now instead of ground penetrating radar, we use magnetometric surveys. That can be used for geophysical surveys, that can be used to find the big metallic objects in the ground, and so on. So there are a number of applications in oil and gas industry too. So that basically helps to automate this service and to make the service much faster.
To increase the solutions for this kind of field. Yeah.
That's an example of what we were speaking in the previous slides. So sometimes you need to inspect objects which are high. For example, flares or towers or high-rise tanks or high-rise chemical reactors. And doing this manually, again, as a routine basis is not an easy task, right?
Yeah,
so the results are not consistent. What UGCS allows to do is to do the 3D scan of the object and then to plan the facade scan of the object. So we can automate the vertical flight against the object and get the consistent photographic results of what we need to inspect.
Perfect. So, this is the case study. It happened in the refinery station in China. Just before we, as a first step, we planned the mission, like using UGCS or DJI pilot, and the drone then will take off and start taking the pictures. So in this very huge station, it's about 7.2 square kilometer covered by a drone with a 140 K photos, so, and a data size of 2 terabyte. So you will have, like as I mentioned before, you will have the data archive for this, or a copy of the real world, whether it's for inspection, whether it's for progress monitoring, if there is like construction is happening in this area. So from this whole map, you can have the ROI of, or the region of interest. Like for example, here we have the storage tank, all the fully departments of this station. You can have it as an ROI, and then you can just like zoom in, zoom out, inspect, and have the fully measurements. You can have the fully control over this map. As I mentioned, it's a real copy of the real world. So here are other examples: the torch tower, the chimney. So you have the full control of the station as a copy in your laptop, whether it's like for data collection, data archiving, studying, analyzing. You can have a lot of different application for this kind of thing.
I think I can give one more real-world example from this region. Last year, we finished a project with one of local customers for industrial objects, which was a big plant with around like 1 by 1.5 kilometers. And we used DJI drones with Ugcs to basically make a photogrammetric survey. And the initial thing, the subcontractor who was actually flying, they were expecting to complete this job in 3-4 days. With a flight automation and proper flight planning, we completed the job in 4 hours.
Wow. And
that's basically the big cost difference in terms of doing the job.
Course.
And as a result, now the customer has a complete digital twin of the facilities. So they can use it not only for future drone surveys, but they use it as a daily basis for the training, for the simulation of the processes and so on.
This is really, really something huge that the drone is offering for it. So here it's about the AI analysis and reporting from Atlas.
Yes, exactly. Right. We were speaking about Atlas in the few times in the previous slides, and what is shown here actually, another capability of Atlas, as I mentioned, it's an AI platform which allows you to detect objects quickly. So what Atlas does, and that's what you see here, that you can upload all the imagery from the drone, and Atlas will stitch them into the one map. And then after it was stitched, you can run the detector to find different objects on this map. So as a result, you see the map with the objects highlighted, plus you have the report of how many of these objects are found, what size of them, where are they, and so on and so on and so on. And that's again to stress it's a user trainable system. So in this particular picture we are looking for vegetation, but if you want to look for the cracks on the pipes, if you want to look for the cracks in concrete, whatever you can imagine. And that's again, that can be done for multispectral imagery too. So thermals, multispectral, all is supported.
Perfect. Eventually we'll speak about the products. We were speaking about different solutions. All of them can be covered with the Matrix 300. Matrix 300 is I can describe it as the beast drone. There's nothing, it cannot be done with this drone. It's the different payloads or the sensors that are available with this drone is really huge. So M300, it can fly up to 15 kilometer, and it can the flight time is like around 55 minutes without a payload. For example, if you mounted like the U10, the U10 will minimize the flight time to up to 30 minutes, around 30 minutes. With the H20T, you will have like 40 minutes with the drone. So, and as well, it's waterproof, dustproof, up to IP45 rating, and it have the 6 directional, omnidirectional sensors for obstacle sensors. As I said, it's compatible with a lot of different payloads and sensors. Like the P1, like the L1, this is from DJI, the U10, that's the one we mentioned, and the other products that comes from Ugcs for the magnetometer or the GPR. It's all fully compatible with the Images 300.
what we do here also for M300, we have a special system which we call SkyHub. SkyHub is basically the integration point for unusual payloads, for non-standard payloads. So SkyHub is basically the onboard PC with a real true terrain following system attached to that, and it works as an interface between DJI onboard SDK and custom payloads. That's how we integrate GPR, how we integrate magnetometers. That's the same way we integrate oil spill detection sensors and many other payloads. One of the examples from today we are speaking about oil and gas, but I have another example from mining industry where we integrated an eco sounder using this approach, which basically helps to the companies to provide bathymetric service of the water bodies. And there, what is important is to have understanding of the depths, right, and the bottom profiles. So with SkyHub and true terrain following system, that can be done very precisely and without actually doing bathymetric service physically with some ropes or weights. So that simplifies the operations big time. Yeah, we mentioned that's oil spill detection sensor. That's just how the sensor looks like. And again, the highlights its benefits is basically can detect any hydrocarbon on the water. It can detect it on in any weather conditions like rough or calm waters, which is a big advantage over traditional detection technologies. And we can detect it day and night, which is also very important feature because, for example, thermal cameras, they can't detect oil spills at night. You need to have a sunlight.
Sure.
Or if you go for radar detection, then you need to have wind. Otherwise, without wind, the oil will not be detectable. So that's just another example of how integration of the drones, DJI drones, and different payloads can help industries to run the business better.
Perfect. So I think this is all for our presentation. Let's see if someone has any question. We will be happy to answer, of course. So I'll check the chat.
So hopefully we get very nice questions today.
Yeah, actually we have one from a customer. How to fly with a GPR autonomous within 0.5 meter to 1 meter? Is it using UGCS SkyHub?
Yes, exactly the point. So UGCS SkyHub is attached to M300.
The drone, yeah.
The radar altimeter is also attached to SkyHub, and that's all integrated with UGCS application and GPR for collecting the data. So that's exactly the idea behind GPR application with the drone, that you need to be exactly at half a meter to get steady results. Otherwise, these results are pretty much difficult to interpret.
Correct. So, any other questions, guys? Let's give some time to wait for someone. Do we have a solution for H2S? Yes, actually there is the one I mentioned before. It's the Sniffer 4D. Sniffer 4D, you can customize it up to your application. As I said, you can put as up to 8 different gases, and H2S is one of them, of course. So you can see here the target gas is H2S and other customized gases. It's up to your application. We can customize it. And you will have the real-time reading, and as well, as I mentioned before, you can connect it to a software in your laptop, and you'll have the real visualization integrated with a 2D map. So you will have a better idea about what is happening in this certain area or in this certain point, etc. Question, is there any particular model for GPR to be used with M300?
Currently, we integrate a few specific models from a Latvian-based manufacturer, and there are a couple of different types of them. There's shortwave, the high frequency ones for mainly for the ground analysis, like to see what is under the sand or different types of soil. And the other model is a low frequency one to look under deeper into deeper places. For example, one of the examples of this long wave technology, we used it in Greenland to find World War II fighter, which was lost in a glacier. And that was found on the depths of 130 meters under an ice. So that's basically the currently. And why we use this GPR? They are specific to the drones because they're very small and lightweight. So it's not heavy, so M300 can lift it.
Perfect. We have another question. Sorry. For exploration and engineering used, can the drone collect the data more than geographic survey? Well, yes. Have you done any mapping projects? So basically, for the photogrammetry, you have different solutions from DJI. Like for example, you have the thermal mapping. You can do the thermal mapping. You can do the RGB normal mapping using P1, and you can do the LiDAR mapping using the DJI L1, just using laser beams. So have you done mapping projects? Well, as I mentioned in the first of the presentation, DJI worked a lot in different projects with the oil and gas companies in worldwide. So they have done a lot, of course, for mapping projects. If you mean like for the oil and gas, yes, it's been done for the other as well, for the other application, for example, for the construction, for the agriculture, etc. Yes, there is a lot of examples I can share with you if you'd like. It's no problem.
I think important point to add here, the drones for mapping have been used for one serious reason, right? When you need a high resolution on the ground. So if this is a requirement of a mapping project, the drone is unbeatable in that. And so DJI with all these high resolution cameras can generate really great results pretty much quickly.
Of course. Can GPR solution help explore crude oil, and what is the detection range?
Not really. GPR will not help in that because crude oil will not be visible on GPR, first of all. GPR is very well used to see such things like buried pipes, infrastructure. To a certain extent, it can see the water table levels. For example, if you're in a desert and you want to understand how deep the water is, in a dry sand, it's pretty much a nice application that you can detect water at the depths up to like 30 meters. It can tell you, for example, clay levels, because clays are typically, as a type of soil, are not RF prearmable, so you can see the clay levels under the ground. That's kind of things. Crude oil, unfortunately, won't be visible there. Yeah. And crude oil depths are much deeper.
Yeah. Topographic survey. Of course, you can do this with the M300 and the other compatible payloads like P1. You will have the topographic
survey. For topographic survey, one thing we can do with Atlas too. Atlas can build elevation profiles. So
it can, yeah.
It does mapping and elevation profiles at both times, and then that can be exported to normal GIS systems to process and to enrich the data later.
It is compatible with the, because of the formats. It's
absolutely. Yeah. We do export traditional GIS formats out.
Perfect. We have another question. Can a pre-recorded mission in UGCS be triggered externally? Are there any APIs for this?
The general answer is yes. It can be currently, without any modifications, it can be triggered either by pilot or it can be triggered by the operator in command and control center. Both are capable to trigger a mission. The only limitation here is legally the pilot should still be in control, so the pilot will stand with a remote anyway in the field. So but that's to emphasize that that's not a technical limitation, it's a legal limitation, right? So there is an API in UGCS which can be used for integration with other systems, and obviously that can be used for integration also for trigger the mission, to select the mission, and to integrate, for example, with the drone boxes. But that's something not available from out of the box. So that will be the customization or custom integration with a particular application.
Okay, perfect. Okay. Any other questions? Let's give it for 2 minutes, 2 more minutes to see if someone have anything.
Maybe while we are waiting for questions from our guests, maybe we need to ask our guests about their ideas, how do they want to use drones today.
Yeah.
So feel free to write what you think about it, and maybe we can cover this in a short couple of sentences.
Yeah, please. Like, what is your main application that you are willing to have with a drone? You can just write it in the chat box, and maybe we will help each other. Give you an idea. Give us an idea. Anyone? If a gas reading is exceeded during a mission, the alarm generated, can it be integrated with a third-party system, like into the control center SCADA system? Up to my knowledge, the alarm that you can put it, the alarm is in the controller itself. So in the settings, you can just put the value, okay? And then if the real-time reading exceeded this value, the speaker of the controller will start beeping. But for the integration with the third-party systems, I have to double-check for this. Like, it's a very interesting question, and I have to double-check for it because it is important maybe to just increase the possibilities. Maybe it can be done so, but
I think today we speak about 2 different solutions for the same task, right? And there are obvious some technical differences. We can do that with per-gram sensor and UGCS. We can send the alarm to any external applications you would like with the Sky app.
Perfect.
But the drawback, we are not that sophisticated in terms of visualization, because what you showed today with another solution, with DJI solution, there is a really nice visual thing where you point the laser and so on.
Yeah.
We don't have that, but we have the capability to integrate.
Oh, this is perfect. Yeah, so we have maybe we can integrate the both.
Yeah, maybe we can take the best from both worlds.
Yeah, maybe.
Do the job.
But it is a good question. The payload from DJI, I have to double check if it is possible, and I will let you know. Depot, yeah. We have thanks for your presentation. You're most welcome, sir. It would be great to schedule another session for public safety operation and maintenance. We'll do for sure. We will plan for this as soon as possible, and we will announce it. Okay, so I hope it was knowledgeable, this presentation, and you enjoyed us. And thank you for participating and joining us and giving the time to learn about this technology. I support the sniffer for DMAP can provide CSV-based report. Yeah, of course. After the mission is done, you'll have the PDF report, you'll have the CSV report. So yeah, you will have it. And for any other next webinar, we will be announce it, and we will send you the invitation, of course. So thank you again. Thank you, everyone. Thank you for joining and giving the time. Thank you, Pavel.
Thank you very much for giving an opportunity to talk today. And thanks to all the guests for interesting questions too.
Yeah, thank you. See you soon. Take care.
See you. Bye-bye.